Question 2. Figure 2.1 shows a man pushing down on a lever to lift one end of a heavy log. So the heavy log is here. We've got a lever. So A. State the term used to describe the turning force exerted by the man. So the term that they wanted here is called moment. So you should know the meaning of this term, because in the next few questions we'll be using it. So for B part 1, figure 2.1 shows the force acting as the man starts to lift the heavy log. So we have 400 newtons, the distance 1.2 meters from the pivot, 0.3 meter from the pivot to the log. So calculate the force exerted by the lever on the heavy log. So to solve this question, we should know that the sum of clockwise moments is equal to sum of anti-clockwise moments. Forgot to include a s here. Remember to keep the s after moment because it's really important. So moments, to calculate the moments, it is force times the distance. So basically we have force 1 into distance 1 is equal to force 2 into distance 2. So therefore we have distance 1 is here, so 1.2 meters into 400 newtons. It's force into distance, and that is equal to, for the anti-clockwise moment we'll have 0.3 meters, and since we do not have the force shown over here, we're going to leave it as F, as that's the value you have to find. So if we rearrange the formula for F, we will take the 0.3 to the left hand side of the equation, and that will go in division. So therefore we will have 1.2 into 400 divided by 0.3, and that will be equal to 1600 newtons. That's how we solve B part 1. As for B part 2, describe how the man can use a smaller force to lift the heavy log. So if you use a longer lever, it will be easier to lift the heavy log. So that's the answer they want for part 2 here, and yeah, that's how you solve question 2.